Hello and welcome to this lesson, which is all about getting actors of a particular class. In this lesson, we're going to learn how we can get all the actors of a particular class that exists in a level, and we're going to learn all about arrays and how we can call functions on them. Okay, so in the previous lesson, we started coding this win level volume that we'll use as a trigger point for completing our level. When the player enters it, we want it to run some code that checks if there's any crystals remaining in our level. And if no crystals remain, the game will load the next level. Now, how do we check to see if we have collected all the crystals in our level? Well, if we right click to call the blueprint action menu in the event graph here, we can scroll all the way down to the utility section. And in the utility section, if we keep scrolling down, we can find some functions called get all actors. And there's different results here. We can get all actors of class here. And it says this is a slow operation, use with caution, and do not call it every frame. Okay, and the reason it's telling us that is because when this function is called, by default, it's going to return every single actor in your level. So you can imagine it could be quite heavy. But we can use this actor class here and filter just for the actors that we want to search for. For example, if we only want to return all of our crystals in the level, we can drop this down and just filter by the crystal blueprint. But look how it returns our crystals. There's this strange pin here that we haven't seen yet. And this is an array. It's returning an array of all our crystal actors. An array is a collection of elements of the same type, and each array element has an index. And the first element of an array starts at index 0. Let's visualize this a bit by taking a look at some of our crystals. All these crystals here are of the same type. They are this BP crystal class. Now let's imagine these crystals are in an array. An array is a collection of elements of the same type, and each crystal here is an array element. And we have 5 elements in our array here. There's 5 crystals. And each array element has an index. And the first element of an array has an index of 0, not 1. So it's important to note that your first element of your array doesn't have an index of 1. It's always 0. So in blueprints, arrays are symbolized by these dotted squares, and with arrays and blueprints, we can call functions on them to alter them or find more information out about them. We can find array functions in the blueprint action menu, under utilities, and then under the array category. There's lots of functions to call here, and I won't be covering every single one, but one function here is the length function, and the length function returns how many elements are in your array. So if we get all the actors of our crystal blueprint class and call the length function, it will return how many crystals are in our level. So your challenge right now is to get all your crystal actors and get the length of the array that's returned, and then with the length value, check to see if it's above 0. So we call this get all actors of class function, and we filter the results by searching for our crystal blueprint. And this will return an array here that contains all of our crystal actors that exist in our level at the moment that this function executes. So with the return value, we can drag it out and we can call functions on it by coming to the utilities category and then the array category. And we can find out what each function does here just by hovering over it, and it gives us some more information. Now we want to call the length function. This returns how many elements are in the array. So in our case, it's going to tell us how many crystals are in our level. And we can check to see if there's more than 0 crystals in the level. And to do this, we can drag out the return value of the length and we can put in the greater than symbol to get an integer greater than integer here. Okay, so we're asking a question here. We're asking, is there any crystals remaining in our level? So with all these nodes selected, we can actually encapsulate this down into a function called any crystals remaining. Now you may have noticed this function is color-coded blue. If, for example, we get a getActorLocation function, notice how it's green, okay? And if we right click and use the action menu here and just type in array and take a look at any functions here, we can see that sometimes they're color coded green and sometimes they're color coded blue. So this is actually a symbol for something here. So we're going to move straight into the next lesson and learn all about this and how this affects our functions and our blueprints. So when you're ready, I'll see you in the next lesson. Hello and welcome to this lesson, which is all about pure and impure functions. In this lesson, we're going to learn about the difference between these functions, and we're also going to learn about pure const functions. Okay, so in the previous lesson, we set up some code in our win volume to tell us if there are any crystals remaining in our level, and we encapsulated this into a function named anyCrystalsRemaining. But this function isn't returning a result for us. But before we get to that, I want to point out that this function here is an impure function. Blueprint functions can be pure or impure, and we've been using pure and impure functions throughout this course. Impure functions are color-coded blue. And one thing to notice here is that impure functions have execution pins on them, when pure functions do not have any execution pins. And impure functions can affect state. Now, what do I mean here when I say they can affect state? Well, I mean affecting the state of the actor they are called on, or affecting other actors or objects that exist in the game world. Using the setActorLocation function is an example of affecting state, as this function changes the location of an actor in the world. Therefore, it's changed the state of the actor, and setting variables in blueprints is also another example of affecting state. So impure functions can affect state. Now, pure functions, on the other hand, are color-coded green, and they are generally used for calculations and returning data. One way to think about pure functions is that you ask a question and you get an answer. And pure functions have no execution pins, and your first response might be, well, how or when do pure functions run? Well, pure functions run whenever any of their return values are used in your code. And the most important bit of info to take away here is that pure functions promise never to affect state, meaning they promise never to affect the member variables or the state of the actor on which the pure function is called, or any other actor or object in the game world. This is also stated here in the function section of the Unreal Engine 4 documentation. It says functions can either be pure or impure, and the main difference is that pure functions promise not to modify state or the members of the class in any way, while impure functions are free to modify state. But here's the twist here: even though pure functions promise never to affect state, they still can affect state, and this isn't mentioned here in the documentation. But we can enforce this promise. In order for a pure function to never be able to affect state, you want to mark the pure function as const to make it a pure const function, which enforces that this promise of protecting member variables and state will never be broken. We can change if functions are pure or pure const via the details panel when we are inside the function or when we have the function selected on the event graph. So your challenge right now is to mark your anyCrystalsRemaining function as pure, and then mark the function as const to make it a const pure function. Marking the function as const might be a bit trickier to find, but I promise you it's there, so try digging around to find it. And the final step of this challenge is just to make sure to return the Boolean result on your function. So pause here to attempt this challenge, and then once you're ready, we can go through this together. So when we select our anyCrystalsRemaining function, which is an impure function, we can make it pure by checking the box on the details panel, which is just pure. So we now make this a pure function when we check this box. And we can see that the function changes entirely. It removes all of its execution pins, so it's no longer in the execution flow here. And there's no pins at all on this pure function. We can enter the function by double-clicking on it, and we can view our code. And we want this function to return this Boolean result here. So we can't see any details about the function on the details panel because we don't have the function selected. So if we just select the function, or if we select the entry node here, it will bring up the details. Now, we want to add an output. If we add a new parameter for the output here, it will add this return node onto the graph for us. We want to make sure that we hook up all the execution pins in here to make sure that our function fully executes, and we can hook up this Boolean value to the parameter. But there's something I want to show you here. If we remove the output values, the return node still stays, and we can create output pins on this return node just by dragging and dropping pins onto the node, and that adds a new return value for us. Okay, if we come back to the event graph, we can see that our pure function now has a return value on it. And the pin is actually named return value as well, which is fine. We can think of this pure function as asking a question. The function name is the question, and the return value gives us the answer. So this is a pure function, and Unreal tells us that pure functions promise never to affect members or state of the class, meaning if we create a variable now, and just throw it into this function and try set it, Unreal tells us that we shouldn't be able to do this. Okay, if we hit compile, it should give us an error, and we can see it doesn't give us an error. We shouldn't be able to call functions like set actor location, which is clearly changing the state of an actor somewhere in the game. Okay, and if we compile, Unreal still doesn't care about this. This is because this function is not a pure const function. If we select the function again, and on the details panel, we can expand this little white arrow where it says show advanced, and we can check this const box to make it a pure const function. And we can see that listed just on the top here as well. And now if we compile, Unreal starts throwing errors at us, telling us that we cannot compile this blueprint because these functions and variables are changing state. Okay, we can remove these because I'm just using these as an example. And if we hook this up and hit compile, we see we have no problem now. Because this function, as it stands and exactly how we want it to stand, it does not affect state. So this is perfectly okay for us. And this is what we want for pure functions. We never want pure functions to affect the state of a class. Now I'm just going to switch back to my event graph, and we can test this out just by using a branch here with our function. So something overlaps our win volume. If it's the player, are there any crystals remaining? If there are, we can test just by printing a string and saying crystals still remaining. And if there's no crystals remaining, we can just print that message. So let's hit compile and save. I'm just going to test this by making sure I've got my win volume in my level. And I'm also going to just remove the crystals that are far away from the start of the level, just so I can easily test this here. I'm just going to hit play and enter my volume, and we can see it prints a message saying that there's crystals still remaining. Now let's put this to the test. Let's collect all our crystals here and roll back into this. And what does it say? It tells us that there's no crystals remaining. Okay, great. So the next step for this is to make it so if we do collect all our crystals and enter the volume, the game will load a new level. So that's just what we're going to be tackling in the next lesson.